All right, we're all good.
All right. Yep,
I think so.
All right.
I'm ready.
Well, welcome to our research report number 3. My name is Andy Williams. Uh, Guys, please introduce yourselves.
I am Bernard Berchie.
My name's Caleb Peck.
All right, and the subject of our group's research report is the question: how many hours do Ohio University students spend working out each week depending on class rank? The most important thing in a college student's daily life is their physical and mental health, as a healthy mind and body allows students to perform optimally in the classroom. The impact of this report is to understand why students are or aren't getting enough exercise in their weekly lives and whether or not class rank has anything to do with that result. As researchers, our group was able to control the subject group to be exclusively students at Ohio University Athens campus. And we were also able to control the time period to which we asked all students to, or sorry, we asked all subjects to record their workout hours. There were many variables that we could not keep constant, and some of which may have affected the results of our research. For example, some students may have a busier schedule in their lives, which means they won't have the same amount of opportunities to exercise like the others. Another example would be any of the subjects being affiliated in a team sport or ROTC. These groups require a larger amount of time dedicated to exercise, so if any of the subjects were a member of any of these groups, their weekly workout hours would be drastically greater than the rest. As our group gathered the necessary data for the report, we expected to find no significant difference in the workout hours between class ranks, as we believed that there was an issue with lack of exercise. It would be a school wide problem rather than a problem with specific class. As shown on the right, there is a table with the raw data we collected from our reports. In order to better understand the data in the table, some context is needed. Our research was conducted in a categorical way, as all exercise hours were recorded and categorized by 3 different groups. The independent variable for our report was the class rank of the students, and this was a nominal variable, as each separate class rank was labeled with a unique number, with number 1 for sophomores, number 2 for juniors, and number 3 for seniors. The dependent variable for our report was the total hours of exercise recorded in the week. The dependent variable was discrete, as all numbers recorded were listed in the whole numbers, representing the hours of exercise. After the initial data was recorded, calculating a descriptive statistics table was the next course of action. From this table, we can see the mean, standard deviation, and etc. about our 3 independent variables, as well as total cumulative. For sophomores, the mean is 6 and the standard deviation is 2.121. For juniors, the mean is 6.11 and the standard deviation is 2.028. For seniors, the mean is 5.67 and the standard deviation is 4.062. As for total cumulative, the mean is 5.93 and the standard deviation was 2.2786.
All right, cool. All right, so now we're going to be transitioning on to the assumption. First, we're going to go over the homogeneity of variance. This assumption implies that the variances of the populations from which the samples are drawn are equal. In ANOVA, it's assumed that the variability within each group is similar across all groups, basically. And the second assumption we're going to be going into is the independence of observations. For the independence of observations, this assumption states that the observation within each group are independent of each other. In other words, basically, the values in one group should not be influenced by the values in another group. For the last assumption, or the third assumption, would be normality. For normality, this assumption suggests that the data within each group are normally distributed. While ANOVA is robust to violations of normality when sample sizes are large, it is still ideal for the data to be approximately normally distributed within each group. Now, after talking about all of these three assumptions, the most important assumption not to violate is the assumption of homogeneity of variance. This is because this assumption can lead to inflated type 1 error rates, making it more likely to detect statistically significant differences when they do not truly really exist. Violating the assumption of homogeneity of variance can also affect the reliability of the F-test in ANOVA. So now we're going to be going into the one-way ANOVA, which goes much more in depth. For the one-way ANOVA, our null hypothesis is that there will be no significant difference in mean weekly hours spent working out between the sophomores, juniors, and seniors. Our alternative hypothesis, on the other hand, is at least one of the group's mean weekly hours spent working out is significantly different from another, with a 0.05 alpha and a degrees of freedom numerator of 2 and degrees of freedom denominator of 24. Got an F critical value for our set of data, which was at 3.043. So our F critical value was at 3.403. Below, you would see like my data set over there for the ANOVA, which has all the between groups number, the within group total. Now, going on, our calculated F critical value was 3.403, which I mentioned before. Our F obtained, on the other hand, from the ANOVA was 0.058. Since our F obtained does not fall within the rejection region of being more extreme than our F critical value, we must fail to reject the null hypothesis. Basically, in conclusion, there's no significant difference in the mean weekly hours spent working out between sophomores, juniors, and seniors. Looking at our results, basically, it would not be appropriate or necessary to perform a Fisher's LSD test. This is because we fail to reject our null hypothesis, meaning that none of the groups differ significantly. Therefore, it is not necessary to find out which groups specifically differ significantly, which is the purpose of the Fisher's LSD test. Now I'm going to move it on to Caleb to take over.
The Fisher's LSD test is a testing procedure that compares several groups. Our T critical value was 2.064 with an alpha level of 0.05. Our degrees of freedom was 24, and our standard error was 1.364. When comparing sophomores to juniors, the sig value of 0.936 is greater than the alpha value of 0.05. Therefore, there is no significant difference between these two groups. While comparing sophomores to seniors, the sig value of 0.089 or 0.809 is greater than the alpha value of 0.04. Therefore, there is no significant difference between those groups either. And when comparing juniors to seniors, the sig value of 0.747 is greater than the alpha of 0.05. Therefore, there is no significant difference between these groups. So in conclusion, due to every sig value being greater than the alpha value, there's no significant difference between sophomores, juniors, or seniors' workout times each week. When talking about the effect size or the magnitude of effect, the magnitude of effect determines the actual size of the effect. Our effect using ETA squared is 0.005. When interpreting our effect size, we used ETA squared, and the thresholds are from 0.01 or less is considered a small effect size, 0.01 to 0.06 is considered a medium effect size, and 0.06 to 1.4 is considered a large effect size. Therefore, our effect size is considered small due to being less than 0.01. Having a small effect size means that there is not a strong comparison between any of the groups. So in conclusion, our research report question is: how many hours do Ohio University students spend working out each week depending on class rank? The reasoning behind this report is to determine and understand why students are or are not getting enough exercise in their weekly lives, and whether or not the reasoning is due to their class rank. We expected to find no significant difference in workout hours between class ranks, as we believed if there was a difference in workout hours, it would be a university-wide issue rather than a specific class issue. Therefore, our null hypothesis is that there will be no significant difference in mean weekly hours spent working out between sophomores, juniors, and seniors. And after analyzing our research question, all of our evidence supports failing to reject the null hypothesis, as there is no significant difference between the class ranks to fault them for the lack of weekly exercise.
Thank you very much for your time today, and I hope you found our report to be very informative. Everyone, say goodbye.
Bye.
Bye-bye.